Question 241. TerramEarth plans to connect all 20 million vehicles in the field to the cloud. This increases the volume to 20,600,000 byte records a second for 40 terabits an hour. How should you design the data ingestion? A. Vehicles write data directly to GCS. B. Vehicles write data directly to Google Cloud PubSub. C. Vehicles stream data directly to Google BigQuery. D. Vehicles continue to write data using the existing system, FTP. The best approach is for vehicles to write data directly to Google Cloud PubSub, option B. Google Cloud PubSub is designed for high-throughput, real-time event ingestion and messaging. It can handle millions of events per second with low latency, ensuring that data from millions of vehicles is efficiently ingested into the cloud. PubSub allows for scalable message processing and integrates well with other Google Cloud services like Dataflow, BigQuery, and cloud storage for further processing and analytics. Explanation: TerramEarth needs to handle 20 million records per second, each 600 bytes, leading to 40 terabits per hour. This is an extremely high ingestion volume that requires a scalable and reliable event-driven system. Option A, vehicles write data directly to GCS, is not suitable because GCS is an object storage service, not designed for real-time ingestion at this scale. Writing directly to GCS would lead to bottlenecks and inefficient data handling. Option C, vehicles stream data directly to BigQuery, is not feasible because BigQuery is designed for batch processing and querying, not real-time ingestion from millions of vehicles. Streaming into BigQuery would also be costly and inefficient. Option D, continue using FTP, is outdated and unsuitable for handling real-time high-volume data ingestion. FTP is not designed for streaming large-scale telemetry data and would introduce significant latency and reliability issues. Conclusion: Google Cloud PubSub is the best solution because it can handle massive-scale data ingestion, ensuring reliability, scalability, and seamless integration with downstream processing tools like Dataflow and BigQuery. Question 242. You analyzed TerramEarth's business requirement to reduce downtime, and found that they can achieve a majority of time saving by reducing customers' wait time for parts. You decided to focus on reduction of the 3 weeks aggregate reporting time. Which modifications to the company's processes should you recommend? A. Migrate from CSV to binary format, migrate from FTP to SFTP transport, and develop machine learning analysis of metrics. B. Migrate from FTP to streaming transport, migrate from CSV to binary format, and develop machine learning analysis of metrics. C. Increase fleet cellular connectivity to 80%, migrate from FTP to streaming transport, and develop machine learning analysis of metrics. D. Migrate from FTP to SFTP transport, develop machine learning analysis of metrics, and increase dealer local inventory by a fixed factor. The best approach is to increase fleet cellular connectivity to 80%, migrate from FTP to streaming transport, and develop machine learning analysis of metrics, option C. Explanation: TerramEarth wants to reduce downtime by focusing on minimizing customer wait time for parts. The key issue identified is the 3-week aggregate reporting time, which delays parts availability predictions. 1. Increasing fleet cellular connectivity to 80% ensures that more vehicles can transmit real-time telemetry data. This improves visibility into part failures, allowing predictive maintenance and proactive inventory management. 2. Migrating from FTP to streaming transport eliminates batch delays and enables real-time data ingestion. Streaming ensures that critical vehicle data is processed immediately rather than waiting for periodic uploads. 3. Developing machine learning analysis of metrics enables predictive analytics for parts failure, allowing TerramEarth to optimize inventory and distribution, reducing downtime for customers. Why other options are less suitable? Option A, CSV to binary, FTP to SFTP, machine learning, does not address the real-time data bottleneck. SFTP is still a batch-based process and does not solve the latency issue. Option B, FTP to streaming, CSV to binary, machine learning, improves data transport but does not increase fleet connectivity. Without higher connectivity, many vehicles will still report infrequently, delaying insights. Option D, FTP to SFTP, machine learning, increasing dealer inventory, does not improve data latency. Increasing inventory without predictive analytics may lead to inefficiencies and higher costs. Conclusion: Option C is the best choice because it ensures real-time data collection, eliminates batch processing delays, and enables predictive analytics for better parts forecasting, directly reducing customer wait times and downtime. Question 243. Which of TerramEarth's legacy enterprise processes will experience significant change as a result of increased Google Cloud Platform adoption? A. OpEx-CapEx allocation, LAN changes, capacity planning. B. Capacity planning, TCO calculations, OpEx-CapEx allocation. C. Capacity planning, utilization measurement, data center expansion. D. Data center expansion, TCO calculations, utilization measurement. The best answer is capacity planning, TCO calculations, and OpEx-CapEx allocation, option B. Explanation: Adopting Google Cloud Platform, GCP, significantly alters how TerramEarth manages its IT infrastructure and operations. The key legacy enterprise processes that will experience major changes include: 1. Capacity planning. In an on-premises environment, companies must plan for hardware purchases, scaling, and infrastructure upgrades. In GCP, scalability is dynamic, reducing the need for long-term capacity forecasting. 2. TCO, total cost of ownership, calculations. A cloud adoption shifts cost models from large upfront capital expenditures, CapEx, to ongoing operational expenses, OpEx. This changes how costs are calculated, with a focus on cloud usage efficiency instead of hardware depreciation. 3. OpEx-CapEx allocation. Moving from on-prem to GCP means shifting IT spending from CapEx, buying and maintaining hardware, to OpEx, paying for cloud services as needed. Organizations must adjust financial models accordingly. Why other options are less suitable? Option A, OpEx-CapEx, LAN changes, capacity planning, includes LAN changes, which are less significant. Cloud adoption mainly impacts WAN and internet-based networking rather than internal LAN changes. Option C, capacity planning, utilization measurement, data center expansion, includes data center expansion, which becomes less relevant since GCP eliminates the need for on-premise data center growth. Option D, data center expansion, TCO calculations, utilization measurement, is incorrect because cloud migration reduces the need for data center expansion, not increases it. Conclusion: Option B is the best choice because capacity planning, cost modeling, TCO, and financial restructuring, OpEx-CapEx, are the most significantly impacted legacy enterprise processes when moving to Google Cloud Platform. Question 244. To speed up data retrieval, more vehicles will be upgraded to cellular connections and be able to transmit data to the ETL process. The current FTP process is error-prone and restarts the data transfer from the start of the file when connections fail, which happens often. You want to improve the reliability of the solution and minimize data transfer time on the cellular connections. What should you do? A. Use one Google Container Engine cluster of FTP servers. Save the data to a multi-regional bucket. Run the ETL process using data in the bucket. B. Use multiple Google Container Engine clusters running FTP servers located in different regions. Save the data to multi-regional buckets in US, EU, and Asia. Run the ETL process using the data in the bucket. C. Directly transfer the files to different Google Cloud multi-regional storage bucket locations in US, EU, and Asia using Google APIs over HTTPS. Run the ETL process using the data in the bucket. D. Directly transfer the files to a different Google Cloud regional storage bucket location in US, EU, and Asia using Google APIs over HTTPS. Run the ETL process to retrieve the data from each regional bucket. The best approach is option C. Explanation: TerramEarth needs a more reliable and efficient solution than FTP, which is error-prone and inefficient over cellular networks. To improve reliability and minimize data transfer time, the best approach is 1. Directly using Google Cloud Storage, GCS, instead of FTP ensures that data transfers are resumable and fault-tolerant, preventing restarts when connections fail. Google APIs over HTTPS provide a more reliable and scalable way to upload data. 2. Using multi-regional storage improves availability and reduces latency. Multi-regional buckets automatically replicate data across multiple locations within a continent, ensuring redundancy and high availability for ETL processing. 3. Running ETL from GCS ensures that the data is processed efficiently without requiring FTP-based intermediaries, reducing errors and delays. Why other options are less suitable? Option A, GKE cluster for FTP, multi-regional GCS, ETL from bucket, still relies on FTP, which is the core problem. Even with containerized FTP servers, failures would still cause data transfer restarts. Option B, multiple GKE FTP clusters, multi-regional GCS, ETL from bucket, is even more complex, requiring multiple clusters for FTP, which does not solve the fundamental reliability issue. Option D, regional storage instead of multi-regional, is less suitable because regional storage is limited to a single region, reducing availability and increasing latency for global data retrieval. Question 245. TerramEarth's 20 million vehicles are scattered around the world. Based on the vehicle's location, its telemetry data is stored in a Google Cloud Storage, GCS, regional bucket, US, Europe, or Asia. The CTO has asked you to run a report on the raw telemetry data to determine why vehicles are breaking down after 100k miles. You want to run this job on all the data. What is the most cost-effective way to run this job? A. Move all the data into one zone, then launch a cloud Dataproc cluster to run the job. B. Move all the data into one region, then launch a Google Cloud Dataproc cluster to run the job. C. Launch a cluster in each region to preprocess and compress the raw data, then move the data into a multi-region bucket and use a Dataproc cluster to finish the job. D. Launch a cluster in each region to preprocess and compress the raw data, then move the data into a region bucket and use a cloud Dataproc cluster to finish the job. The best approach is option D. Explanation: TerramEarth has 20 million vehicles generating telemetry data stored in regional GCS buckets across US, Europe, and Asia. The goal is to run a report on all the raw telemetry data while keeping costs low. 1. Processing data in each region first minimizes cross-region network transfer costs. Running a cloud Dataproc cluster in each region to preprocess and compress the raw data reduces the volume of data that needs to be moved, saving costs. 2. Storing the processed data in a regional bucket instead of a multi-regional bucket is more cost-effective because regional storage is cheaper than multi-regional storage. 3. Using a single cloud Dataproc cluster in one region to complete the final job ensures centralized, efficient processing without unnecessary duplication of resources. Why other options are less suitable? Option A, move all data into one zone, then use Dataproc, is not feasible because zonal storage does not exist in GCS, and transferring raw data to a single zone would be expensive and inefficient. Option B, move all data into one region, then use Dataproc, leads to high cross-region transfer costs since the raw data is large. Pre-processing before moving reduces these costs significantly. Option C, use multi-region storage for final processing, increases costs unnecessarily. Multi-regional storage is more expensive than regional storage and is not needed for a single final processing step. Question 246. TerramEarth has equipped all connected trucks with servers and sensors to collect telemetry data. Next year they want to use the data to train machine learning models. They want to store this data in the cloud while reducing costs. What should they do? A. Have the vehicle's computer compress the data in hourly snapshots and store it in a Google Cloud Storage, GCS, nearline bucket. B. Push the telemetry data in real time to a streaming data flow job that compresses the data and store it in Google BigQuery. C. Push the telemetry data in real time to a streaming data flow job that compresses the data and store it in Cloud Bigtable. D. Have the vehicle's computer compress the data in hourly snapshots and store it in a GCS cold line bucket. Option D, have the vehicle's computer compress the data in hourly snapshots and store it in a GCS cold line bucket, could be correct if the data is rarely accessed and only used for long-term storage before machine learning training. However, it is important to consider retrieval costs. Key considerations. Cold line storage has lower storage costs but higher retrieval costs. If TerramEarth plans to frequently access the data for ML training, cold line may not be the best option. Nearline is designed for data accessed once a month or less, while cold line is meant for rare access, once a year or less. If ML models need regular retraining, nearline would be a more cost-effective balance. If ML training is only done once or twice a year, and data retrieval can be carefully planned, cold line may be the cheapest choice overall. When option D, cold line, is better. If telemetry data is stored long-term and accessed rarely for model training. If the retrieval can be batched strategically to avoid frequent access costs. When option A, nearline, is better. If ML models need more frequent training, requiring periodic data retrieval. If avoiding high retrieval costs is important. Conclusion: if ML training is rare, once a year or less, cold line, option D, is the most cost-effective. If training happens more frequently, nearline, option A, is better to avoid high retrieval costs. Question 247. Your agricultural division is experimenting with fully autonomous vehicles. You want your architecture to promote strong security during vehicle operation. Which two architectures should you consider? Choose two. A. Treat every microservice call between modules on the vehicle as untested. B. Require IPv6 for connectivity to ensure a secure address space. C. Use a trusted platform module, TPM, and verify firmware and binaries on boot. D. Use a functional programming language to isolate code execution cycles. E. Use multiple connectivity subsystems for redundancy. F. Enclose the vehicle's drive electronics in a Faraday cage to isolate chips. The best choices are A. Treat every microservice call between modules on the vehicle as untested, and C. Use a trusted platform module, TPM, and verify firmware and binaries on boot. Explanation: for fully autonomous vehicles, security is a critical concern, especially for software integrity, secure communication, and protection against cyber threats. 1. Treating every microservice call between modules as untested. A. Ensures that even internal communication is authenticated and encrypted, preventing unauthorized access or manipulation of vehicle systems. This follows zero-trust security principles, which are essential for autonomous systems. Using a trusted platform module, TPM, and verifying firmware and binaries on boot. C. Ensures the integrity of the software stack, preventing tampering or malware infections. TPM is widely used in secure boot processes to ensure that only verified and signed software runs on the vehicle. Why other options are less suitable? B. Require IPv6 for connectivity to ensure a secure address space. While IPv6 has a larger address space, it does not inherently improve security. Security depends on encryption, authentication, and access control, not just IP addressing. D. Use a functional programming language to isolate code execution cycles. Functional programming can help in software reliability, but it does not directly enhance vehicle security. Security measures like TPM and zero-trust communication are more critical. E. Use multiple connectivity subsystems for redundancy. This improves reliability, not security. Security measures focus on protecting the system from unauthorized access and tampering. F. Enclose the vehicle's drive electronics in a Faraday cage. While a Faraday cage can block external electromagnetic interference, it does not protect against software-based cyber threats, which are the bigger concern for autonomous vehicles. Conclusion: the best security measures for autonomous vehicles are A. Zero-trust communication between microservices, and C. TPM with secure boot verification. These measures provide strong protection against software tampering, cyber attacks, and unauthorized access, making them the most effective security choices. Question 248. Operational parameters such as oil pressure are adjustable on each of TerramEarth's vehicles to increase their efficiency. depending on their environmental conditions. Your primary goal is to increase the operating efficiency of all 20 million cellular and unconnected vehicles in the field. How can you accomplish this goal? A. Have your engineers inspect the data for patterns, and then create an algorithm with rules that make operational adjustments automatically. B. Capture all operating data, train machine learning models that identify ideal operations, and run locally to make operational adjustments automatically. C. Implement a Google Cloud data flow streaming job with a sliding window, and use Google Cloud Messaging, GCM, to make operational adjustments automatically. D. Capture all operating data, train machine learning models that identify ideal operations, and host in Google Cloud Machine Learning, ML, platform to make operational adjustments automatically. The best approach is B. Capture all operating data, train machine learning models that identify ideal operations, and run locally to make operational adjustments automatically. Explanation: to increase the operating efficiency of all 20 million vehicles, including both cellular connected and unconnected vehicles, an on-device machine learning solution is necessary. 1. Capturing all operating data allows for pattern recognition and helps train machine learning models that can determine the optimal oil pressure settings based on environmental conditions. 2. Running the model locally on the vehicles ensures that even unconnected vehicles can adjust their operational parameters in real time, without relying on a constant network connection. 3. Machine learning enables dynamic optimization instead of relying on static rules or human-defined thresholds, improving efficiency across various environments. Why other options are less suitable? A. Manual inspection and rule-based automation. Rule-based systems lack adaptability and cannot handle complex patterns as effectively as machine learning models. C. Streaming job with cloud data flow and Google Cloud Messaging. This requires a constant network connection, which excludes unconnected vehicles from receiving updates. D. Hosting the model in Google Cloud ML platform. Running models in the cloud means vehicles would need an active internet connection for every adjustment, which would not work for unconnected vehicles. Conclusion: option B is the best choice because it enables both cellular and unconnected vehicles to autonomously optimize efficiency using machine learning without relying on constant network connectivity. Question 249. For this question, refer to the TerramEarth case study. To be compliant with European GDPR regulation, TerramEarth is required to delete data generated from its European customers after a period of 36 months when it contains personal data. In the new architecture, this data will be stored in both cloud storage and BigQuery. What should you do? A. Create a BigQuery table for the European data, and set the table retention period to 36 months. For cloud storage, use Xutil to enable lifecycle management using a delete action with an age condition of 36 months. B. Create a BigQuery table for the European data, and set the table retention period to 36 months. For cloud storage, use Xutil to create a setStorage class to none action when with an age condition of 36 months. C. Create a BigQuery time partition table for the European data, and set the partition expiration period to 36 months. For cloud storage, use Xutil to enable lifecycle management using a delete action with an age condition of 36 months. D. Create a BigQuery time partition table for the European data, and set the partition expiration period to 36 months. For cloud storage, use Xutil to create a setStorage class to none action with an age condition of 36 months. The correct answer is option C. Explanation: to comply with GDPR, General Data Protection Regulation, that requires deletion of personal data after 36 months, the most efficient and scalable approach is: for BigQuery, use a time partition table with an expiration period of 36 months. This ensures that any data older than 36 months is automatically deleted without requiring manual intervention. Time partition tables in BigQuery allow data to be automatically managed and expired based on time, like ingestion time. Why not use table retention period? Table retention periods apply to the entire table and would require manual deletion of old data or manual rolling windows. This is inefficient and does not align with GDPR compliance. Using partition expiration aligns perfectly with GDPR since it automatically deletes data per partition when the expiration period is reached. For cloud storage, use lifecycle management with a delete action and an age condition of 36 months. This ensures that any object older than 36 months is automatically deleted from the storage bucket. Why not use setStorage class to none? Setting the storage class to none is not a valid action in cloud storage lifecycle management. The correct action for compliance is delete to ensure that the data is entirely removed after 36 months. Analysis of other options. Option A, incorrect. Setting the table retention period to 36 months in BigQuery is not recommended because it applies to the entire table, not individual partitions. This approach lacks granular control over data expiration, making it harder to comply with GDPR. Using XUTIL with delete for cloud storage is correct but does not resolve the BigQuery compliance issue. Option B, incorrect. Setting the table retention period in BigQuery is inefficient, as explained earlier. Using setStorage class to none in cloud storage is not valid. Storage classes control the cost and performance of storage but do not delete data. This approach does not comply with GDPR deletion requirements. Option D, incorrect. Although using time partition tables with 36-month expiration is correct for BigQuery, using setStorage class to none in cloud storage is invalid. The action does not achieve data deletion as required by GDPR. The correct action for cloud storage is delete, not changing the storage class. Why option C is the best choice? BigQuery, time partition tables with a 36-month expiration ensure automatic deletion of data without manual intervention. Cloud storage, enabling lifecycle management with a delete action and a 36-month age condition ensures the data is automatically deleted. This approach directly satisfies GDPR compliance by automating data deletion across both storage solutions. Question 250. For this question, refer to the TerramEarth case study. TerramEarth has decided to store data files in cloud storage. You need to configure cloud storage lifecycle rule to store 1 year of data and minimize file storage cost. Which two actions should you take? A. Create a cloud storage lifecycle rule with age, €30, storage class, €standard euro, and action, set to cold line euro, and create a second GCS lifecycle rule with age, €365, storage class, cold line euro, and action, delete euro. B. Create a cloud storage lifecycle rule with age, €30, storage class, cold line euro, and action, set to nearline euro, and create a second GCS lifecycle rule with age, €9, storage class, cold line euro, and action, set to nearline euro. C. Create a cloud storage lifecycle rule with age, €90, storage class, standard euro, and action, set to nearline euro, and create a second GCS lifecycle rule with age, €9, storage class, nearline euro, and action, set to cold line euro. D. Create a cloud storage lifecycle rule with age, €30, storage class, standard euro, and action, set to cold line euro, and create a second GCS lifecycle rule with age, €365, storage class, nearline euro, and action, delete euro. The correct answer is option A. Why option A is the best answer? Minimizes storage cost by moving data to cold line after 30 days. Deletes data after 1 year, ensuring no long-term storage cost. Cold line storage is ideal for infrequently accessed data, archival, and costs significantly less. Meets the requirement of retaining data only for 1 year. Analysis of other options. Option B, incorrect. This option incorrectly moves data from cold line to nearline, which increases the cost instead of reducing it. It also fails to define a clear deletion policy after 1 year. Option C, incorrect. This option delays moving data to cold line by 90 days, which results in higher storage costs for the first 3 months. Additionally, it does not define an automatic deletion after 1 year. Option D, incorrect. This option proposes moving data to cold line after 30 days, correct. However, It then sets a delete action after 365 days but uses nearline storage as an intermediate step, which increases the cost unnecessarily. It is also inefficient since cold line is already the cheapest storage class.